Alright, so today we're doing Unit 4, Linear Relationships, and Lesson 4, which is Function Notation and Evaluation. So, our standard today will be to use function notation, evaluate functions for inputs in their domains, and interpret statements that use function notation in terms of context. So what is function notation? Function notation, hang on, where's my little pen? There we go. So function notation is basically where we take our output and we put it as what we call f of x, or some function of some independent variable. The outside letter is the name of the function, and the inside is what we call the input. So we replace y with f of x, and we read it as f of x. So f of x is the name of the function. X tells you that x is the input, and what the function is equal to tells you the function rule. So what you need to apply to that input. So we have three functions here, and functions can be in several forms, okay, slope-intercept form, or it can be a quadratic equation. And it says here to write the following in function notation. So write the following in function notation. Function notation. So to take a function and to put it into function notation, so we take our equation, okay, our equation is going to be typically y equals something, and we need to get it into what we call function notation. So function notation is where we replace the y with f of x, okay, so it's going to be f of x is equal to 3x plus 2. That's what goes on the line, okay. Now on the other line we have h is equal to 4t squared minus 1. So this is going to be h of t is equal to 4t squared minus 1. So that's how you go from equation to function notation. Okay, equation to function notation.
So you do
you replace your dependent variable with whatever it is of whatever that function is. Typically you do f of x. You could have also done this as f of t if you wanted to, but we just used h.
How come on one you said f of x, and that's pretty much completely different from the actual equation, but on
So then we want to evaluate each one. So f of x, how do we write this? We write f of 5 is equal to, we replace all the x's. Okay, you got to be able to replace all the x's. That gives me f of 5 is equal to, what's 3 times 5? Yes, Paris?
15.
Okay. So we're going to replace our x with 5. So this is 3 times 5, which is? 15 plus 2 is? 17. So this is how we write our answer in function notation, okay? So the answer is f of 5 is equal to 17. So guys, so we're going to do the same thing with 0. We're going to plug 0 into the function. So I'm going to use a different color because they look very close to each other. So this is f of 0 is equal to 3 times 0 plus 2. This is f of 0 is equal to, what's 3 times 0?
0.
0 plus 2 is?
2.
2. F of 0 is equal to 2. Makes sense? And then the last one, what are you going to plug in for x here? 1. So I'm just plugging in 1, and what do I get as a result? 5. Very good. So it says here, write the following in function notation. We did. Evaluate the given inputs. We did that. Then state the domain and range of the 3 points found. Okay, so it wants us to state the domain and range. So the domain over here is all of the x values. So what did we put into the function?
5.
Yeah, we put 0, what else? 1 and 5 into the function, right? That's our domain. And what did we receive when we put those values into the function? That's our range.
Different numbers.
Good, and what are those numbers? 2.
Range.
Good, 2, 5, and
0.
it's the value that you get when you
17.
17. So that's your domain and that's your range. You guys see the difference there?
Yeah.
So the range is what you receive when you plug in the independent variables, okay? So then moving on, we have to evaluate for t into this function. So this is going to be h of 3 is equal to 4 times 3 squared minus 1. You have to do exponents first. So what's 3 to the second power?
9.
What's 9 times 4?
28.
36.
Oh.
So h of 3 is equal to 36 minus 1, which is, you guys know what 36 minus 1 is? 35, good. So let's try the next one. So what are we plugging in for t? 2. What do I have to do first in evaluating this?
2 times 2.
Good, what's 2 times 2?
4.
What's 4 times 4?
16, 15.
15, very good, guys.
Wait, 4 times what?
4 is 16 and minus the 1.
4 times 4 is 16, right?
Yeah, 16 minus 1.
Oh, okay. I get it.
You get it now?
Mm-hmm.
And then the last one, h of negative 1, is equal to 4 times negative 1 squared minus 1. What's negative 1 to the second power?
Negative.
It would be 1.
It would be a positive 1, right? Because a negative times a negative is a positive.
Oh, it's raining.
No.
So what's positive 1 times 4?
That's right. I did.
What?
In the middle of a problem. Negative 1 to the second power is positive 1. What's positive 1?
4.
So then we need to continue. So this becomes 4 minus 1, which is
3.
3. h of negative 1 is 3. So these are our 3 answers that we get. We have to now identify the domain and range from these. So let's look at our domain. Yes?
That's right.
Yeah.
But since you since you had that extra 1 from the exponent, wouldn't you add that?
What?
Like, because, you know how you have the x value, in there, and it says negative 1 to the squared, right? And you multiply it by itself, that would be a positive 1, right?
Positive 1 times 4 is
Okay, I get it.
4, and then minus 1 is 3.
Yeah,
So yeah, there would be a 1 times 1, but it just didn't change anything.
Yeah, I just got confused because I forgot that I was multiplying.
Okay. So then moving on from the lesson here, we're going to label all the domain values. So are the domain values the inputs or the outputs? The inputs. What are our inputs? Put them in order, smallest to biggest.
Negative 1, 2, and 3.
Good. Negative 1, 2, and 3 is your domain. Now we're going to go with the range. So the range are the what kind of values?
Y values.
Good, the output values. So what are our output values in order?
30, no.
3.
15 and 35.
Good. 3, 15, and 35. Those are our range values. Everybody see where those came from?
Yeah.
Okay. So once you guys get this done, we're going to do a word problem. All right, we're continuing with the lesson. So now we're going to talk about function. So function notation in context. The function c of x represents the cost of gallons of heating oil and can be represented by the function c of x is equal to 4x plus 6. What is the independent variable? What do you guys think?
The number of gallons.
Independent variable is either going to be x or c of x. Which one do you think is independent? Which one do you think controls everything?
C of x.
So let's think about the context here. So the function c of x represents the cost for x gallons of heating oil. So if you're buying x gallons of heating oil, the cost is controlled by the amount of oil you buy, right? So which one's going to be the independent variable?
X.
Good, the x, the gallons of oil. Does that make sense? Why? Because the independent controls the dependent. Obviously, the price of the the cost of the heating oil is dependent on how much you buy. Okay? So then, what is the dependent variable? C of
C of
x, because C of x is dependent on how many gallons you buy. The cost
So
is
C of
dependent.
X is your cost.
Is your cost.
Okay.
Exactly, that represents your cost. And then we want to find out what's the cost for 3 gallons of heating oil. Well, what am I going to plug in 3 for? X. So it's going to be C of 3 is equal to 4 times 3 plus 6, which is C of 3 is equal to 12 plus 6, which is 18. Very good. So it costs, well, $18, right? If it's in dollars, whatever it is. We don't know what the units are, so we just say 18, that's fine. Could be 18,000 if that's what it was going by. We don't know that information. So explain what C of 1 equals 10 means in the terms of the context. So C of 1 equals 10. What is the 1? Is the 1 your independent? It's your X, right? So that means that we bought how many gallons of heating oil? 1 gallon of heating oil. I spelled gallon wrong. 1 gallon of oil costs how much? 10. We'll just say 10. We'll just assume it's dollars, $10. That's really cheap, but so 1 gallon of oil costs $10. Makes sense how we got that from this?
Yeah.
And the next one says, is C of 5 equals 10 part of this function? Explain why or why not. What do you guys think?
Why?
No, why not?
Because it doesn't equal $10.
No, because this means that we bought 5 gallons of oil, right? And 5 gallons of oil costs a lot more than $10, doesn't it?
$50.
It would be 5 times 4, which would be 20. It would be $26, right? So is this part of the function?
No.
No. It's not part of the function, okay? So if you want to check it, you take whatever your independent variable is, plug that in, and see if that's what you get. Okay? So like technically speaking, this would be 10 equals 4 times 5 plus 6. So it'd be 10 equals 26? No. Not part of the function. Yeah, does that make sense to you guys?
Yeah.
Yeah, Janelle, I'll go back to the first part.